Launch checked and countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed.
Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Hello everyone, it's Wednesday, June 8th, and you're looking at a live view of Falcon 9 awaiting liftoff, currently scheduled at 5:04 p.m. Eastern Time. My name is Andy Tran, and I'm a quality engineer here at SpaceX. Welcome to the webcast for the NILESAT-301 mission. NILESAT-301 is a communication satellite that was designed and manufactured by Thales Alenia Space and will provide broadband services to Egypt and neighboring countries in the Middle East and North Africa. Before we learn more about today's mission and payload, let's take a closer look at the Falcon 9 vehicle supporting today's mission. Falcon 9 is our two-stage liquid-fueled launch vehicle and stands 230 feet tall. That is greater than the wingspan of a 747 aircraft. Starting from the bottom of the vehicle, we have our first stage, which is the largest part of Falcon 9. As the name suggests, Falcon 9 has 9 Merlin or M1D engines at the bottom of the first stage, and this allows it to accelerate through the Earth's atmosphere and into various orbits in space. The dark soot that you see around the lower part of the first stage are remnants from its 6 previous launches. After lifting off for the 7th time today, we'll attempt to recover our first stage again on our drone ship that you see on screen. It's named Just Read the Instructions. Today's launch will mark the 156th Falcon 9 launch overall and the 116th Falcon 9 first stage landing. Above the first stage, we have the black carbon fiber inner stage that connects the first and second stages. The inner stage has pneumatic pushers that help the first and second stages separate, and it also houses our Merlin vacuum engine on our second stage that will take our payload to its desired orbit. Above the inner stage and second stage, at the very top of Falcon 9, we have the payload fairing. And as you may have guessed, this is the structure that protects our payload until we reach the vacuum of space. It's made up of 2 carbon fiber pieces that come together to encapsulate the NILESAT-301 satellite. And once we're in the vacuum of space, the 2 pieces will then separate from one another and begin their journey back to Earth. Like our first stage, we will be attempting to recover these fairing halves to fly again in the future as well. For now, let's learn a little bit about our payload flying on board Falcon 9 today, the NILESAT-301 satellite designed and manufactured by Thales Alenia Space.
25 years have passed since the birth of the NILESAT company. The dream began with the launch of the first Egyptian satellite, NILESAT-101, in 1998, manufactured by the French company Matra Marconi, and immediately followed in 2000 by the second Egyptian satellite, NILESAT-102, manufactured by the same company. The 2 satellites were launched by the French company Ariane Space. NILESAT-201 was built and launched in 2010 with a capacity of 26 transponders in the Ku band and 4 transponders in the Ka band. The world is witnessing a technological leap in the field of satellites, and NILESAT has always been ahead of its time. NILESAT has kept pace with huge technological developments in recent years, and in 2016 launched specialized technical, economic and marketing studies. NILESAT-301. A contract has been signed with the French partner Thales Alenia Space for the 3rd generation of satellites NILESAT-301 to be launched from Florida in the United States using rockets from the American SpaceX company in a positive technological mutual relations and cooperation with the American partners. The new Egyptian satellite NILESAT-301 is unique and distinguished, exceeding the capabilities of all previous and current current satellites. NILESAT-301 contains 38 transponders in the KU band, in addition to 6 new transponders in the KA band for broadband internet provision over the Arab Republic of Egypt. Digital broadcasting in the new frequency bands extended KU, used for the first time in the Middle East and Africa, adding new technologies which will be available for the first time to NILESAT customers, like anti-jamming on different frequencies, the ability to identify the source of interference accurately, broader coverage areas, Nile Basin countries, Southern Africa countries with continued coverage of the current regions of the Middle East and North Africa. NILESAT-301, meeting the needs and aspirations of the Arab and African family through more than 50 million viewing points. These are the NILESAT customers. NILESAT, the satellite of the Arab and African families. NILESAT.
So we are just under 5 minutes and counting. At this point, we are getting word that the team is tracking a potential flight issue. For now, we're going to continue to count down as the team works towards resolving that issue. If we do find something that might hinder the mission, we will be stopping the countdown. But for now, we're going to continue forward. We just heard the call out that the Strongback is beginning its sequences to retract. First up is going to be the clamp arms underneath the fairing halves. Those will open up. And then that large truss structure, the Strongback,
retract,
will begin to recline away from the vehicle to its pre-launch position about 2 degrees away. And we should start to see some movement on screen. There it is, the clamp arms right underneath the payload fairings. Those are opening up. The Strongback is part of a larger structure called the Transporter Erector. We also refer to that as the TE. Its job is to route the vehicle's fluids, power, and telemetry umbilicals from the ground systems to the rocket and satellites until Falcon 9 goes on internal power and clears the pad. Our team actually began loading propellant at the T-minus 35-minute mark, and we're nearly full on both stages. Falcon 9's first and second stages use the same 2 propellants, and as our fuel we use RP1 or Rocket Propellant 1, and as our oxidizer we use super chilled oxygen, and we also refer to that as LOX. The liquid oxygen is chilled well below its boiling point, and that increases its density, allowing us to load more into the first and second stage LOX tanks. In addition to these 2 payloads, to these 2 propellants, we also use the chemical TTAB, which stands for triethyl aluminum and triethyl borane, as an ignition source. The combustion of RP1 and LOX is what makes the rocket go, but it's TTAB that sets the match to the propellant mix. So if you imagine a barbecue with charcoal and air, until you actually light a match to it, you won't get any tasty food, or in our case, you won't get liftoff. So we're about 2.5 minutes until liftoff. If you've been following social media, you know that we started the day with about a 40% probability of violating launch weather requirements. It's actually reduced down to 20% now. We're primarily looking at the cumulus and anvil clouds, which are typical in summer afternoon weather patterns in Florida. But aside from that, the launch vehicle, satellite, and range are all looking good for an on-time liftoff at 5:04 p.m. Eastern Time from Space Launch Complex 40.
Stage 2 LOX load complete.
So with that call out of stage 2 LOX load complete, that is the last of propellant loading for both stages on our vehicle. So we are fully topped off and ready to lift off in about 90 seconds.
Gas closeouts.
You can see some white clouds starting to build up around the vehicle. That is normal and expected for us at this time in the liftoff.
Falcon 9 is in startup.
Now that we are in startup, that means that both stages are now beginning to pressurize for launch.
Falcon 9, NILESAT-301, LD is go for launch.
The launch director is a go for launch. We are working no issues at this time on the vehicle or payload. Let's listen in for the liftoff of NILESAT-301.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
M1D chamber pressure is phenomenal. Pitching downrange.
Plus 40 seconds into the mission, Falcon 9 has successfully lifted off from Space Launch Complex 40 at Cape Canaveral Spaceport Station, carrying the NILESAT-301 satellite to a geosynchronous transfer orbit. Right now, we are throttling down the first stage engines in preparation for a period known as max Q. This is where we'll experience the highest amount of aerodynamic pressures on the vehicle.
Max Q.
Now that we've passed max Q, we are now bringing those engines back up to full power. In about a minute, we have a couple of events happening in quick succession. First up will be main engine cutoff, also known as MECO, followed by stage separation, and then SES-1, also known as second engine start 1. During main engine cutoff, those 9 engines will shut off. During stage separation, the first and second stages will separate from one another, and then during SES-1 or second engine start 1, we'll have that single Merlin vacuum engine on the second stage. It will ignite and continue to carry the NILESAT-301 satellite to its targeted drop-off orbit. Shortly after we see ignition of the second stage engine, we are expecting those fairing halves to deploy and exposing, again, that NILESAT-301 satellite to the vacuum of space. Get some really cool ground shots of the Falcon 9 vehicle. Coming up on main engine cutoff in a few seconds here.
MECO. Stage separation confirmed. And MVAC ignition.
So we got successful main engine cutoff, successful stage separation, and you can see on the right-hand side of the screen that Merlin vacuum engine on the second stage has indeed had started up and is now propelling the second stage with our payload to its drop-off orbit. So coming up, we'll have fairing deploy in about 5 or so seconds.
Fairing separation confirmed.
And there you see it. The 2 fairing halves have separated and are falling away from the vehicle, now exposing the NILESAT-301 satellite. As a reminder, again, we are going to be attempting to recover those fairing halves with the help of our recovery vessel, Doug. For now, we're about 4 minutes into the mission. Things are looking great. So you have a couple of views on screen. On the left-hand side is a view from the top of the first stage, looking down. It is making its way back to our drone ship. Just read the instruction, which is parked in the Atlantic Ocean. And on the right-hand side, again, is the view of the Merlin vacuum engine. On the opposite side of that engine is the NILESAT-301 satellite. So we're currently in the first of 2 planned MVAC burns for the second stage. As for the first stage, at around the T+6 minute and 27 second mark, you should see on screen the first stage's entry burn. It's one of 2 burns needed to land the first stage today. For the entry burn, we relight the center engine, engine number 9, and then partway through that, we'll relight engines number 1 and 5, so that we'll have 3 total M1D engines helping to slow down the vehicle as it passes through the Earth's atmosphere. You'll see the exhaust start as a circular plume from the center engine and then change shape to a longer, narrow plume when the 2 other engines reignite. Reusability is key to lowering the cost of spaceflight, which enables more investments in critical scientific research. The Falcon 9 first stage that is supporting today's mission will be performing this entry burn for the 7th time, having previously supported 2 Starlink missions, the Axiom-1 mission, the Inspiration4 mission, and the GPS-III and 5 mission. So about a minute away from that entry burn. If you look on the bottom left-hand side of your screen, there is a velocity gauge of the first stage. And so as we go through that entry burn, you'll start to see that we are slowing down the speeds of the first stage. But actually, even after we complete the entry burn, as we go through the denser parts of the Earth's atmosphere, we'll continue to scrub speed. In fact, the majority of the speed is actually scrubbed by the Earth's atmosphere. Talked a little bit about the engines and the different engines on the Falcon 9 vehicle. On the right-hand side of the screen, that is the Merlin vacuum engine. It's optimized to perform in the vacuum of space and can produce over 220,000 pounds of thrust. The engines on the first stage are
Stage 1 entry burn
optimized to perform at sea level, and they can produce over 190,000 pounds of thrust during both ascent and descent. And you can see that we have indeed started our entry burn. This is expected to last for about 20 seconds before we shut off those 3 engines once again. And while Falcon 9 makes its way back,
Stage 1 entry burn shutdown.
You may notice the different sit markings on the outer coverings of the rocket. Pretty much as we're returning to Earth, we're flying through our own exhaust. And so that's where the sit will start to build up around the Falcon 9 first stage. So we did have successful entry burn. The first stage has one more burn to go. That's going to happen in about a minute and 15 seconds. Before we start the landing burn on the first stage, we are going to be listening for a call out for the second stage, which is SECO. That stands for Second Engine Cutoff 1. The second stage engine will shut off and enter a coast phase for about 20 minutes, and then we'll actually be reigniting the second stage engine for a second time. We'll shut it off for a second time, coast for a little bit longer before we'll be deploying the NILESAT-301 satellite. So we have a couple more sequences to go through before we get that satellite free to its targeted orbit.
MVAC shutdown. Expected loss of signal, Cape. Stage 1 landing burn.
So we did get confirmation of a successful second engine cutoff, and we've also begun the landing burn on the first stage.
Nominal orbit insertion.
So that call out for nominal orbital insertion is what we're waiting for the second stage. Again, it is now parked and in its coast phase. So here we're going to see if we can land this first stage for the 7th time on our drone ship. have it. That is SpaceX's 116th successful Falcon 9 first stage landing, as well as SpaceX's 99th mission flying a reflown Falcon booster. Our mission isn't over just yet. The second stage is now embarking on its coast phase between the first and second burns of the MVAC engine. After the coast phase, we will relight the MVAC engine for a second time, a little bit after the T plus 26-minute mark. So we'll see you back here in about 20 seconds. In the meantime, we'll leave you with some space tunes. Welcome back to the webcast of the Falcon 9 mission carrying the NILESAT-301 satellite designed and developed by Thales Alenia Space. We're coming up on the second burn of the upper stage engine in just under 40 seconds. To recap what's been happening so far, we had a smooth liftoff at 5:04 p.m. Eastern Time. 2.5 minutes later, our first and second stages successfully separated from one another. The first stage landed for the 7th time on our drone ship, Just Read the Instructions, and we had a successful second stage engine cutoff. It's currently coasting right now before we again reignite that second stage Merlin vacuum engine. So right now the second stage is positioned over Africa, and this burn is expected to last for about a minute. Hopefully we get some views, but depending on our acquisition of signal, we may or may not get views, but we should get confirmation here shortly that the second stage engine has indeed reignited with second engine start 2. So we are waiting waiting on some ground station coverage. So we might not be able to get confirmation of that second engine start and subsequently the second engine cutoff at this time. But give us a few minutes here. We're going to check in with the teams and hopefully get that confirmation for you.
Acquisition of signal, good burn.
So we are about a few minutes away from that ground station. So we should be getting confirmation of SES-2 and SECO-2 here in a couple of minutes. So we are expecting confirmation here in about 90 seconds. Again, as a reminder, ground station coverage is how we get data back from the vehicle. So if we have spots where we aren't connected to a ground station, we can't get that data. So as the second stage continues to orbit around the Earth, we'll wait for it to pass over a ground station and get that data and confirm SES-2 and SECO-2.
Acquisition of signal, hard to be stuck.
Nominal orbit insertion.
So there was the call that we were waiting for. So we did have a good burn and a good orbital insertion. So we are coasting for just a few more minutes before we begin the final sequences to deploy the NILESAT-301 satellite. So if you are just joining us, we have just one more major milestone coming up to complete today's mission, which of course is deployment of the NILESAT-301 payload that you see on screen right now from the top of Falcon 9's second stage, which is scheduled to take place about a minute from now. As previously mentioned, the NILESAT-301 is one of the latest generations of high-tech satellites with technical and broadcast capabilities, excelling all previous Egyptian satellites. Adding on to current coverage locations, the satellite will have the ability to operate 40 transponders covering new regions such as the Nile Basin countries and Southern Africa. In addition to providing broadband internet all over Egypt, NILESAT-301 will be capable of frequency maneuvering, anti-jamming, and geolocating the source of anti-jamming. Now, in a few seconds here, we should be witnessing that NILESAT-301 satellite deploy from our second stage.
Payload deploy confirmed.
And there you have it. We've received and see on screen successful separation of the NILESAT-301 satellite from Falcon 9's second stage. With that, we are going to be bringing our webcast to a close. We're going to take some time to thank the NILESAT team for entrusting us with today's mission, and of course to all of our viewers. If you're interested in more things and more updates about SpaceX, tune into our social media channels for all things SpaceX. Thanks again, and we'll see you very shortly.